Hi students, this is Viswanath, chemistry faculty for NEET and IIT exams. Last class we completed standard enthalpy of formation. Now see the related numericals. Calculate the standard enthalpy of formation of CH3OH from the following data. 3 equations are given. Now standard enthalpy of formation of methyl alcohol we should calculate. So here methyl alcohol combustion reaction is given. So methyl alcohol CH3OH plus 3/2O2 gives rise to CO2 plus 2H2O. And carbon combustion reaction, hydrogen combustion reaction is given, and corresponding enthalpy changes are also given. The reaction that takes place during the formation of CH3OH is carbon in solid state, C plus 2H2 in gaseous state plus half O2 gaseous state gives rise to CH3OH in liquid state. So this is the required equation. For this reaction, delta FH0 we should calculate. Let it be equation 1. This equation 1 can be obtained from the given reactions. So equation 2 plus 2 into equation 3 minus equation 1. Equation 2 means this one, carbon combustion reaction. So write that reaction, C graphite plus O2 gives rise to CO2, and 2 into equation 3. This third equation, if we multiply with 2, then that is suitable to get our required equation. So 2H2 plus O2 gives rise to 2H2O. We have to add these two reaction equations. Then we can get carbon in the form of graphite plus 2H2 plus 2O2. We have to add these two. 2O2 gives rise to CO2 plus 2H2O. Next, subtract equation 1. What is equation 1? This one. So this equation we should subtract. So subtract that one. That means the signs will be changed. So finally we can get carbon in the form of graphite plus 2H2 plus half O2, 3/2O2 and 2O2. By doing calculation we can get half O2 gives rise to CH3OH. Now standard enthalpy of formation of CH3OH is delta F H0. Here that is missed there. Delta F H0 CH3OH. Then corresponding enthalpy of the reactions. So first equation, second equation enthalpy plus 2 into third equation enthalpy minus first equation enthalpy. Substitute the values. Finally we can get standard enthalpy of formation of CH3OH, that is minus 239 kilojoule per mole. Okay, practice the numericals carefully. See the next numerical. The equation in accordance with the definition of standard enthalpy of formation of CO2 is. So we have to select a suitable equation for standard enthalpy of formation of CO2. According to definition, standard enthalpy of formation of a particular compound means that compound 1 mole is obtained from its constituent elements in their standard state. Here compound is CO2, elements are carbon, oxygen. Carbon standard state in the form of graphite, oxygen standard state, gaseous state. So what is the suitable option? First option is the suitable one. Carbon in the form of graphite plus O2 gives rise to CO2. This is standard state of oxygen, standard state of carbon, and product is CO2. So this option represents standard enthalpy of formation of CO2. In remaining options also we have CO2 as the product, but CO2 is not obtained from elements, that is obtained from other compounds. That's why option A is the answer. Go to the next one. Which of the following values of enthalpy of formation indicates that the product is least stable? So enthalpy formation values are given. From that least stable product we should find out. Enthalpy of formation is negative, then that reaction is exothermic and product is exothermic product. Positive, endothermic reaction, endothermic product. Exothermic means by release of heat energy reaction takes place. Endothermic means by absorbing heat energy reaction takes place. Here say this least stable, this exothermic product, endothermic, endothermic. Already we completed this point. Exothermic products are thermodynamically more stable than endothermic products because in formation of exothermic products, heat energy is released. That's why the formed product has more stability than endothermic reactions. So option A, option B, exothermic products, so they have more stability than these. These two are endothermic products. These values related to endothermic products, between these two, its value is more. That's why this compound is least stable compared to remaining compounds. So option D is the answer. Energy more. In the formation of this compound, more and this much amount of energy is absorbed. So the formed product has least stability. Next, the standard enthalpy of formation at 298 Kelvin for methane CH4 in gaseous state is minus 74.8 kilojoule per mole. The additional information required to determine the average energy for CH bond formation would be. Understand question carefully. Delta F H naught for methane value is given. Now we should find out suitable option which gives additional information required to determine average energy of CH bond formation. For average energy of CH bond formation, which information is required? CH bond, how this bond is formed? H2 molecule is dissociated to hydrogen atoms in gaseous state. Those atoms can combine, can be bonded with carbon atoms. Then we can get CH bond. Okay. For that, suitable one is the dissociation energy of H2 and enthalpy of sublimation of carbon. These two things are required to determine the average energy of CH bond formation. In nature, hydrogen is present in molecule H2 state in gaseous form. So for the formation of CH bond, hydrogen atoms are required. That's why dissociation energy of H2 is needed. And carbon is present in graphite form. Graphite is a solid. That solid form is converted to gaseous state directly. That is called enthalpy of sublimation. Hence, we need dissociation energy of H2 and enthalpy of sublimation of carbon is required to determine the average energy of CH bond formation. Option B is the answer. Now, see this enthalpy of sublimation. What is this? Sublimation process. Already we know that a solid substance is changed to gaseous state without passing through liquid state. That is called sublimation. Here, enthalpy of sublimation means the change in enthalpy when 1 mole of this solid substance is converted to gaseous state directly is called enthalpy of sublimation. A solid substance directly changed to gaseous state, 1 mole of this substance, that is enthalpy of sublimation. Next, standard enthalpy of sublimation, delta H naught. The change in enthalpy when 1 mole of a solid substance sublimes at a constant temperature and under standard pressure, that is 1 bar, is called standard enthalpy of sublimation. So 1 mole of the substance at a particular temperature and 1 bar pressure is changed to gaseous state directly. That enthalpy change is called standard enthalpy of sublimation. Okay students, practice well. We will meet you in the next class.